All right, welcome to Parallelogram Unit, Quadrilateral Unit Day 2. We're going to talk about parallelograms, rhombuses, squares, and rectangles. Not in that order, but that's the idea. So to get started here, in a parallelogram, this is what we talked about in our last lesson. We're just going to do a quick little review. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. All sides are congruent. That's not always true in a parallelogram. It's not always true that adjacent sides are congruent, and it's not always true that non-parallel sides are congruent. For angles, both pairs of opposite angles are congruent. All angles are congruent is not always true in a parallelogram, so I won't check that. It is not true all the time that all angles are right angles, but consecutive angles are supplementary. So these were the properties we learned last time about sides and angles. Diagonals, we also learned that diagonals bisect each other, and that diagonals form two congruent triangles. We're not going to worry about the symmetry part down here at the bottom because we haven't really talked about symmetry. In some school years I've done symmetry earlier in the year, but we haven't done it yet, so we'll skip that. Okay, so now if I come over here to the picture, this should be a review. If you want to pause the video and see if you can answer these questions on your own, that would be a great way to practice. But I will go ahead and do it. AB is 10. Okay, so I'm going to label the diagram a little bit here. AD is 5. BD is this entire diagonal. So BD is 14. That means that each part here will be 7. AC is this diagonal. Since diagonals bisect each other, each part of that diagonal will be 6. The measure of angle ABC, so that's this whole angle here, is 75 degrees. And the measure of angle ACD, now be careful, ACD is just this little angle in here. It's not the whole angle. It's not this whole thing. It's just this part. D. ACD. All right, so let's see what we can do here. BE. BE goes from here to here, and we already said that's 7. DC is this side, which is opposite AB, so that would be 10. BC is the side opposite AD, so it's 5. And AE, we already labeled as 6. Okay? So those are all the lengths. Now let's talk about some angles. I'll switch color here so you can see them a little better maybe. Angle ADC. Angle ADC is this whole angle, which we know because opposite angles are congruent in a parallelogram. We know that this will be congruent to this angle up here. So that is 75. BAD is here. So that's this angle. Well, we know that in a parallelogram, these consecutive angles, like here and here or here and here, have to be supplementary. So this whole angle up here needs to be 180 minus 75. So that's 105. That whole thing is 105. Angle BCD is this angle here, BCD. That's opposite the 105. So it's also 105. Angle BAC. I'm going to draw in, use my highlighter here. BAC is this angle up there, which if you notice, we're making a Z with parallel lines. So that means that it is alternate interior to the 40-degree angle. So BAC, if this one's 40, this one is also 40. And lastly, BCA, so that's this angle right in here. Okay, this whole thing we said has to be 105 because it's across from 105. So if this part is 40, then this part is 105 minus 40, which is 65. Lastly, we can find the perimeter of triangle DCB. DCB is this triangle. And so if it helps, you can draw it separate if you want and put those lengths. So we've got D, C, and B. BC we said was 5. DC we said was 10. And BD we were given as 14. So I can just add those up and I get 29. All right, so parallelogram. Let's go on to a rhombus, or sorry, rectangle. So a rectangle is a parallelogram. You probably learned this in elementary school, that a rectangle is a parallelogram. So if it's a parallelogram, then it has all the properties of a parallelogram. So I'm going to go ahead and check all of those because it will have all of those. But a rectangle has some extra stuff going on. So you might recall from elementary school that in a rectangle we have 90-degree angles. So all angles are congruent and they're all right angles, right? Because they're all going to be 90 here. A new property that you probably don't know is that the diagonals are actually congruent. Okay, so those are the new ones. So we have all the properties that a parallelogram had, plus these new ones. So these are the additional properties. Okay, basically all angles are 90 and diagonals are congruent. All right, so let's do like we did before. AD is 3, AC is 10. So since the diagonals bisect each other because it is a parallelogram, then AE is 5 and EC is 5. AB is square root 91, and the measure of angle ECD, so be careful, ECD is just this little angle here, it's 10 degrees. Okay? So AE equals 5. DC equals, well, it's opposite the square root of 91, so those are equal. BD is the other diagonal here, and that's a little bit trickier, possibly. It's a new property, right? Diagonals are congruent. So we know the other diagonal is 10, so BD is also 10. Angle ECB. Angle ECB is this angle right here. ECB. Sorry, I can't see. ECB. So it's this angle here. Well, remember that this whole thing is 90, so ECB must be 80. BAD, well, that's a right angle, so that's 90. And BAC, so B to A to C, we're talking about this angle here. Well, this angle here will be congruent to this angle there, right? You got that Z going on, so it's 10 degrees. Okay, and that's the properties of a rectangle. Next up, we're going to do a rhombus and a square on the same page. So a rhombus is still a parallelogram, so I'm going to go ahead and check off all the parallelogram stuff. Notice I'm not checking off the rectangle stuff because we don't know that it has the same properties as a rectangle. What do you know about a rhombus? What makes it a special parallelogram? If you don't know, it makes all sides congruent. So all sides are congruent in a rhombus. Non-parallel sides and adjacent sides are also congruent. So those are my new sides properties. How about angle properties? Are there any new angle properties? Not all angles are congruent here. I can tell this one's clearly obtuse and this one's clearly acute. So we don't have any new angle properties. What about diagonals? You may not see it, but these diagonals are perpendicular. And they bisect the opposite angles. So what that means is that this is a right angle here, and that this angle is congruent to this angle, and this angle is congruent to that angle. They're all congruent. Basically what happens here, because these diagonals bisect each other, we end up with 4 congruent triangles. So this angle is congruent to this angle, and this angle. Okay? All right, so let's solve this one. AB is 13. AC is 10, so that's a diagonal. So each half of that diagonal should be 5. And the measure of angle ABE, so be careful about where that is, A to B to E is this small angle here. It's not the whole thing. This one is 20, which tells me this one is also 20, okay? Just to be clear, it's just that small part. So AE is 5. DC is 13, that's opposite the side that is 13. ED is going to be half of the other diagonal. How are we going to find that? we're going to have to use some right triangle skills here for this part. So remember that this side is 13. We have a right triangle in here. So if I take out that triangle, whoops, AED, we know the hypotenuse is 13, so I'm just taking this triangle here. I'm drawing it over here. The hypotenuse is 13 and one of the legs is 5. So we can use Pythagorean theorem to find that third side. So 13 squared equals x squared plus 5 squared. And I think you guys can solve that. When you get your answer, it should be 12. It is also a triple, 5, 12, 13. Okay. Measure of angle DEC. So that's this angle in here. Well, these are perpendicular, so that angle is 90. EBC, E to B to C, oh, I already labeled it as 20 because these are congruent. DCB, DCB is this whole thing here. So let's think about this one. Remember that a rhombus is a parallelogram. So this whole thing and this whole thing need to add up to 180. They have to be supplementary. So this whole thing here is 40, which means that this whole thing should be 140, so that they add up to 180. And then DAC, well, remember we said this one's 140, so half of it is 70, and all four of these angles are congruent. So this one should be 70. Okay? So if we look back for a second at rectangle, we saw that rectangles have some special properties, and you can see it in that table there, but I'll put it up here because I kind of highlighted it to make it show up more. Rectangles had some special properties related to angles. Rhombuses had a couple of special properties related to sides, and they each had a special property or two related to diagonals, okay? When we put all of this together, and all of these things are true, we have a square. So it's basically when a rhombus is also a rectangle, then all of these things are true, and it's a square. So a square has all of those properties, okay? So if we look at this one at the bottom here, ABCD is a square. If BC is 8, then AC is 8. If BE, oh, sorry, so I need to do some more work here, huh? So I know that this is 8, and this is 8. This is a right angle. Can we find this hypotenuse here? So here's a right triangle. The two legs are the same. That actually makes it an isosceles right triangle, or a 45, 45, 90. And if you remember the rule, it just saves you some time. But you can do Pythagorean theorem here. 8 squared plus 8 squared, that's equal to c squared, and then you can square root. Or if you remember the 45, 45, 90 rules, from leg to hypotenuse, we multiply by square root 2. So this AC is 8 square root 2. So that's really the same as the other diagonal as well, because this is a rectangle, right? So diagonals are equal because a square is a rectangle. And they bisect each other, so that means that this part, BE, is going to be 4 square root 2. It'll be half of that diagonal. Okay? Measure of angle AED, well, this is a right angle, right? The diagonals are perpendicular because a square is a rhombus, and in a rhombus, diagonals are perpendicular. And finally, angle EDC. So EDC, well, if this is 90, and this is, we said was 45 because it's isosceles, this is also 45. Or you can think of it as diagonals bisecting those opposite angles in a rhombus. If those opposite angles are both 90, then each half is 45. Okay? So that is a summary of all the properties of these special parallelograms. And now we're going to do some practice. We're going to use these and apply them to some problems. So I'll do a little bit with you and then kind of let you work on it. You can check your answers in Schoology. Okay, so math is a parallelogram with diagonals intersecting at O. So based on these properties, can we classify? So we want to go to the most specific one we can go to. The first thing stated here is that MT is perpendicular to AH. So what that's really saying is that the diagonals are perpendicular. So if those diagonals are perpendicular, then if I go back and I look at my properties, what's the most specific thing I can go to for diagonals are perpendicular? That would be a rhombus, okay? MT congruent to AH, so that would be diagonals are congruent. And the most specific we can get with that is rectangle. So if I go back, I'm gonna put these together with the highlighted because I think it looks prettier. So if my diagonals are congruent, the furthest I can go here before I get to that is a rectangle, okay? All right. For MA perpendicular to AT, so MA perpendicular to AT, that tells me that I have a right angle. And since this is a parallelogram, if I have one right angle, then the opposite angle is also 90. And my consecutive angles will be 90. So all right angles, or all angles are 90, which puts me in the rectangle category, right? I'm given a second piece of information that AM is congruent to MH. So that's this side and this side. Well, since it is a parallelogram, this side will be congruent to this side, and this side will be congruent to this side. So if these are congruent, then all four sides are going to be congruent. So if all the sides are congruent and all the angles are congruent, then we have a square. Okay. MO congruent to OT, so that's this part of the diagonal congruent to that part, AO and OH. So this is basically saying diagonals bisect each other. Well, if diagonals bisect each other, that just means it's a parallelogram. It's not enough for us to say anything further than it being a parallelogram. We need one of those special properties. Okay. Down at the bottom, you have a practice with a parallelogram. I think I'm going to skip that one because we've done a bunch of parallelograms at this point and go on to the other ones. So here we have a rectangle. So AB is 5, AC is 13, so that's this whole diagonal here is 13. So that means that this is 6.5 and this is 6.5. AB, oh wait, did I write the wrong thing? AD is 5 and AB is 12. Sorry about that. So that's 12 and then that one's 5. Okay, and then ECD, and be careful with your angles, E to C to D is this little tiny angle here, 22.6. Okay? So let's see what we can do. AE, we already labeled it, 6.5. DC is opposite the 12, so that's 12. BD is this diagonal. So you gotta think now, what's the length of this diagonal? I only know this diagonal. But in my rectangle, diagonals are congruent, right? So if this one is 13, then this one is also 13. ECB is this angle over here. Well, it's a rectangle, so I know that each of these corners is 90 degrees. So 90 minus 22.6 is 67.4 degrees. Angle BAD, BAD is 90, right? It's a rectangle. And then BAC is this little angle up here, which is alternate interior to the 22.6. So that'll be 22.6 also. Okay, there's a rectangle practice. Now for the rhombus, AB is 10, AC is 12. So this whole thing is 12. That means each part here is going to be 6. And the measure of angle ABE is 36.9 degrees. All right, so AE, 6. DC is this side, so that's 10. ED, I'm missing a side again. So this is a right angle, right? So we can use a right triangle here. Well, this is 6 and this is 10, and we can find that third side. Take a minute and practice Pythagorean theorem. X should be 8, so that's ED. Then the measure of angle DEC is 90. EBC, well, that's this angle up here. So how are we going to find that one? Your properties of a rhombus say that this diagonal will bisect the opposite angle. So if this one's 36.9, that one's 36.9. Then DCB, so this whole thing has to be supplementary to this whole thing. So let's see what that whole thing is. If we take 36.9 and double it, should have had my calculator handy. Okay, so I'm going to do 36.9 times 2. And I'm going to subtract that from 180. And I get 106.2. So that's this whole thing here is 106.2 degrees. Then the measure of angle DAC, so DAC is up here, that's going to be half, right? Because these diagonals bisect this, and they're equal. So half of 106.2 is 53.1. That's a rhombus problem. Then for the square problem, BC is 10. Oh, didn't give you very much there, but that's okay because we can figure it out because we have a special right triangle and it's got all the properties of the rhombus and the rectangle. So BC is 10, which means all the sides are 10, right? What about the diagonals? So remember what we said before, that this diagonal actually splits this square into two 45, 45, 90 triangles. So if the leg is 10, the hypotenuse AC will be 10 times the square root of 2. You could also do Pythagorean theorem and just say AC squared will equal 10 squared plus 10 squared and figure it out that way. So AC is 10 square root 2. Or if you do it this way, you're going to get square root of 200, and that's fine. Then BE is going to be half of that. So if I have my simplified one here, half of that is 5 square root 2, or you could have square root 200 over 2, or a decimal. That's fine if you do a decimal for these. Measure of angle AED, so that's the angle where the diagonals intersect. Since they are perpendicular, that will be 90. And then EDC, well, we just said the diagonals here are bisecting these opposite angles. So all of these little angles, every single one of them, all the way around the square is going to be 45 degrees. So that's 45 degrees. Okay. Oh, I skipped 18, 26, and 32. Let me go back and get those. I don't know how I did that. All right, so let's go back up here to number 18 for a second. So 18, I also want to point out that 18 does not refer back to this information. You can ignore that for this. AE equals EC. Okay. So if AE equals EC, then they have to be equal to each other, right? Because it's a parallelogram. It's a rectangle, it's also a parallelogram, so it's got that property. So I'm just going to set those equal, and then I can solve. So I'm going to subtract 3x on both sides. So 7 equals 2x minus 9. Then I'm going to add 9. So 16 equals 2x. Then my last step here will be to divide by 2 on both sides so that x equals 8. Okay. For 26, angle BAE and angle ECD. So we're using the properties. BAC is here, and ECD is here. What do we know about those two angles? They're equal because they're alternate interior. So I can set them equal. So 5x minus 18 equals x plus 22. And then you just need to solve it. So I'm going to subtract x on both sides. So I get 4x minus 18 equals 22. And I can add 18. 4x equals 40. Dividing by 4 on both sides, and x equals 10. But I'm not done because it actually says to find the measure of angle ECD. So I need to take this x and plug it in to that expression. So the measure of angle ECD is going to be 10 plus 22, which is, oops, my arrow was in the way, 32 degrees. So that's the actual answer to that question. It was kind of a two-step problem, okay? All right, and then the last one, segment EC and segment BD. So it's this half of this diagonal and the other whole diagonal. Well, since the diagonals bisect each other and they are congruent, all four of these pieces will be equal. So really, two ECs will make up all of BD. So 2 times EC equals BD. You should try doing this yourself. So 2x plus 12 equals 6x minus 8. I'm going to subtract 2x on both sides. I'm going to add 8. Sorry, my copy here has a lot of lines on it. 20 equals 4x. Divide both sides by 4 and I get x equals 5. Oh, I didn't find BD in the other one. Boy, I'm all over the place today. We got to find AE. So AE would be equal to EC, right? So AE equals EC, which is x plus 6. So I'm going to substitute in my x here, and I get 5 plus 6, which is 11. So AE equals 11. And we'll go back. I was kind of all over the place. I didn't actually find BD in number 18. I just found the X. I'm going to go back up here. So we found BD, but then we need to take that and we need to substitute that, or sorry, we found X. We need to take that and find BD. So BD is this whole diagonal, which is the same as AC, right? So again, each part here is congruent. So if I plug in the 8 to AE, 2AE will equal BD. Does that make sense? 2 of these will equal this whole thing. Oops, sorry, I'm off the screen. 2 of these will equal the whole thing. So 2 times 3 times 8 plus 7, I'm just plugging in this X here. And then if I evaluate that, let's see, 24 plus 7 is 31, times 2 is 62. That does not seem quite right, does it? My X was 8. Oh, it is right. Sorry, I was trying to look back at this picture again. I was like, that doesn't work with those numbers. Ignore it. This had nothing to do with the values we had up here. Tripped up myself there. Okay. I won't put something confusing like that in your homework or on a test. Either it'll just be something like this or it'll just be these, not where you have to ignore all of this stuff to do something with the same picture. All right, it's just a good way to get a lot of stuff on one page. Okay, so the last page, let's go through some of these because I think it's good practice with the properties. So based on the markings, identify the type of quadrilateral. So here, this is telling us that all angles are congruent. So that makes it a rectangle. Here, all 4 sides are congruent. So that makes it a rhombus. Here, we don't have opposite sides parallel, so it's not a parallelogram. Okay, it's just a quadrilateral. So I'm just going to say it's a quad. Here we have all four sides congruent and all four angles congruent. So this would be a square. On the second row, we just have one pair of opposite sides parallel. That's not enough, right? We need both pairs. Like in 47, 47 is a parallelogram. But 46 is just a quad. We don't know anything more than one pair of opposite sides are parallel. We'll learn about trapezoids a little later in the unit, and this would be a trapezoid. This would also be a trapezoid, as with this one. When we have one pair of opposite sides parallel, we have a trapezoid, but we'll get to that later. Right now, we're just going to call them quads. Okay? Quadrilaterals. All right. Each figure is a parallelogram, so we know all the parallelogram properties are true. That will help us because, for example, in number 51, knowing that this is a parallelogram allows me to say that since this has one mark, this side opposite it would also have one mark because it's a parallelogram, they have to be congruent, as do these, which then tells me all four sides here are congruent. And if this is 90, then the angle opposite it is 90, and consecutive angles are supplementary, so those are all 90. Do you see how I'm using the properties of a parallelogram to extend what I'm given? This is now a square, okay? So that's why it's important that I'm saying it's a parallelogram first. Here it's a parallelogram, and I have diagonals that are perpendicular. So what is it? If you look back at your properties, that would be a rhombus. For 52, we know it's a parallelogram. So that tells me that all four angles here are congruent, which means it's a rectangle. We don't know anything about the sides, so we can't go further than that. In 53, really what this is saying is that my diagonals are perpendicular and they're congruent because each of these four pieces is the same. So if the diagonals are perpendicular and they're congruent, that's a property of a rhombus and a property of a rectangle, which makes this a square. For 54, these four pieces being congruent makes this a rectangle because it will make those diagonals congruent. And then last one, this congruent to this, then also this and this will be congruent, so it's a rhombus. Okay? So I hope that helped. Try the homework, and if you have any questions, let me know.